In the last lecture, we have derived formulas for sin a plus b, sin a minus b, cos a plus b and cos a minus b. Using that, we found out the values of sin from 0 to 360, similarly for cos. So if we know sin a plus b and cos a plus b, can we find tan a plus b? Absolutely. Let us see how we will go for tan a plus b. Tan a plus b can be written as sin a plus b upon cos a plus b. So what is the formula of sin a plus b? Sin a cos b plus cos a sin b. What is the formula of cos a plus b? Formula of cos a plus b is here. Cos a cos b minus sin a sin b. Now if you look at the formulas of sin a plus b or cos a plus b, you will realize that on the right hand side we have terms in cos and sin. Okay, so in case of tan, if I want all my terms on the right hand side to be in terms of tan, what do I mean? In the formula, I should see only tan and not sin and cos. Then how would I go about it? Here, I can say that in my numerator, I have sin a cos b plus cos a sin b. I want to bring tan in my numerator. So if I want to bring tan in my numerator, whatever is sin has to be divided by cos. Okay, whatever is sin has to be divided by cos of the same angle. So here I have sin A. Again here I have sin B. So if I want to convert this sin A to tan A, I have to divide by numerator by cos A. If I want to get tan B from this sin B, I have to divide my numerator by cos b. But as you know, whatever you do in your numerator, you have to do it in your denominator as well. So let us divide numerator and denominator by cos a cos b. Let us divide numerator and denominator by cos a cos b. Here in this step, I have separated out the numerator as well. So, we divide our numerator and denominator by cos A, cos B. In this step, you can see we have separated out the numerator and denominator. So, what do we get? Sin A cos B upon cos A cos B plus cos A sin B upon cos A cos B, whole thing divided by cos A cos B upon cos A cos B minus sin A sin B upon cos A cos B. So what will happen here? Here you can say that sin A divided by cos A, sin A divided by cos A turns out to be tan A. Cos B cancels. Here cos A cancels and sin B divided by cos B becomes tan B. Similarly, cos A cos B cancels. That comes out to be 1, which you can see here. Sin A upon cos A becomes tan A multiplied by sin B upon cos B becomes tan B. So we get a new formula, tan A plus B is equal to tan A plus tan B. Tan A plus B is tan A plus tan B upon 1 minus tan A tan B. Tan A plus B is tan A plus tan B upon 1 minus tan A tan B. So you can similarly derive a formula of tan A minus B which you will see will come out as tan A minus B is equal to tan A minus tan B upon 1 plus tan A into tan B. Tan A minus B is tan A minus tan B upon 1 plus tan A into tan B. Please note down the formulas. Now let us move ahead. Please have a look at this sum. We want to find the value of cos 75. So, which formula will we use here? Obviously, we can use the formula cos A plus B. So, 75 can be written as 45 plus 30. So, cos 45 plus 30 will become cos 45 cos 30 minus sin 45 sin 30. What is the value of cos 45? Cos 45 is 1 upon root 2. What is the value of cos 30? Cos 30 value is root 3 by 2. What is the value of sin 45? Sin 45 is 1 upon root 2. What is the value of sin 30? Sin 30 is half. So 1 upon root 2 multiplied by root 3 by 2 gives us root 3 upon 2 root 2. 1 upon root 2 multiplied by 1 upon 2 gives us 1 upon 2 root 2. If you look at these two things, you will realize that the denominator is common, that is 2 root 2. So cos 75 we can directly write as root 3 1 upon 2 root 2. Now let us move on to the next sum, sin 105. So how can we solve sin 105? We can solve sin 105 by sin 90 plus 15 or sin 60 plus 45. But getting the angle of sin 15 and cos 15 is a bit tedious. We directly know the values for sin 60, sin 45, cos 60, cos 45. So we use the formula sin 60 plus 45. That gives us sin A plus B formula, which is sin A multiplied by cos B plus cos A multiplied by sin B. Here you can see sin 60 plus 45 will be sin 60 multiplied by cos 45 plus cos 60 multiplied by sin 45. What is your value of sin 60? Root 3 by 2. What is your value of cos 45? 1 upon root 2. What is your value of cos 60? 1 by 2. What is the value of sin 45? 1 upon root 2. So root 3 upon 2 root 2 plus 1 upon 2 root 2 will give you root 3 plus 1 upon 2 root 2. Sin 105 is root 3 plus 1 upon 2 root 2. Let us look at this sum, tan 15. So how will we solve tan 15? Tan 15 can be written as tan 45 minus 30. Tan 45 minus 30. So tan A minus B formula is tan A minus tan B upon 1 plus tan A multiplied by tan B. Tan A minus tan B upon 1 plus tan A multiplied by tan B. So what is the value of tan 45? Value of tan 45 is 1. What is the value of tan 30? Value of tan 30 is 1 upon root 3. So 1 minus 1 upon root 3 upon 1 plus 1 multiplied by 1 upon root 3. Okay, so you take the LCM, here you will get root 3. So it will be root 3 minus 1 upon root 3, whole thing divided by this 1 into 1 upon root 3 will become 1 upon root 3. So it will be root 3 plus 1 whole thing divided by root 3. So again root 3 and root 3, this root 3 and this root 3 will cancel. So what will remain? Root 3 minus 1 upon root 3 plus 1. Similarly, you can solve for sine 15, you can solve for sine 75, you can solve for tan 75. Try out various sums. So I give you a few sums, practice on your own. Find the value of tan 75, sine 15, cos 105, sec 15, cosec 75. Please use your brain. You should be able to crack this problems. Okay, let us start this sum. If sine A is equal to minus 5 by 13, where pi, which is 180 degrees, is less than A and A is less than 3 pi by 2. And cos B is equal to 3 by 5, where 3 pi by 2 is less than B is less than 2 pi. So find the value of sin A plus B and cos A minus B. So if we want to find the value of sin A plus B, what is the formula required? Sin A plus B is equal to sin A multiplied by cos B plus cos A multiplied by sin B. Sin A multiplied by cos B plus cos A multiplied by sin B. What do we have with us? We have the value of sin A, which you can see here, and we have the value of cos B, which you can see here. But we don't have the value of cos A and we don't have the value of sin B. So how to find these values? The moment we get these values, our sum is solved. To get cos A, can we use sin A? Yes. Sin A is minus 5 by 13. So what will be sin square A? Sin square A will be 25 upon 169. We know that sin square A plus cos square A will be equal to 1. From that, can we say cos square A is equal to 1 minus sin square A? Perfectly correct. So we will get cos square A as 1 minus 25 upon 169. If you solve, you get cos square A as 169 minus 25 upon 169, which comes out as 144 upon 169. But this is the value of cos square A. We want cos A. So cos A, if you take the square root of both sides, you will get cos A as plus or minus 12 by 13. Plus or minus 12 by 13. So whether it is plus 12 by 13 or minus 12 by 13 will be decided by where the angle A is lying. Okay, what do I mean? We will need to go for quadrants. So look into your sum. Somewhere the information of quadrants is mentioned. Here I am marking it. Your A is greater than 180 and less than 270. So A lies in which quadrant? A lies in quadrant 3. In quadrant 3, value of cos is negative, which I am marking here. So cos A will be minus 12 by 13. Cos A will be minus 12 by 13. Now we want to find sin B. We want to find sin B. Can we find sin B in a manner similar to which we found cos A? Correct. We can. So we know cos B as 3 by 5. So what will be cos square B? Cos square B will be 9 upon 25. Sin square B plus cos square B is equal to 1. So sin square B will be 1 minus cos square B. So 1 minus 9 upon 25. So if you take the LCM and adjust, you will get sin square B is 16 upon 25. But sin B will come out as plus or minus 4 by 5. So whether we should take plus 4 by 5 or whether we should take minus 4 by 5 will be again decided by quadrants. Where is the quadrant available? Look in your sum. Here I am marking it. The quadrant is available here. So your B is greater than 270, less than 360. That means B lies in quadrant 4. B lies in quadrant 4. So in quadrant 4, what do we know? We know that sin is negative. Sin is negative. So sin B will be minus 4 by 5. Sin B will be minus 4 by 5. So now we have got sin A and cos B, which was originally given. We found out the values of cos A and sin B. So can we now find sin A plus B? Similarly, can we find cos A minus B? Please try on your own to get the final answer. So let us check whether your answer is right or wrong. Sin A plus B, if you have done the calculations correct, should come out as 33 upon 65. Sin A plus B is 33 upon 65 and cos A minus B should come out as minus 16 upon 65. Minus 16 upon 65. Can you also find the value for sin A minus B? Also, can you find the value of cos A plus B? Please try. Once you get that, find the value for tan A plus B and also find the value of tan A minus B. A small hint, how will you find tan A plus B? The moment you get sin A plus B and cos A plus B, you get the value of tan A plus B as sin A plus B upon cos A plus B. Use the same logic for tan A minus B. Let us move ahead. Two sums for homework. If sin alpha is equal to 15 upon 17, where alpha lies between pi by 2 and pi, and cos beta is equal to minus 4 by 5, where beta lies between pi and 3 pi by 2, find the values of sin alpha minus beta, cos alpha minus beta, tan alpha minus beta. Another similar sum, if sin A is 4 by 5, where A lies between pi by 2 and pi, and cos B is equal to 5 by 13, where B lies between 3 pi by 2 and 2 pi, find the value of sin A plus B, cos A minus B, tan A minus B. Please pause this video and try to solve the sums on your own. Let us continue. If sin theta is equal to 3 by 5 and theta lies in second quadrant, then find the other 5 trigonometric functions. So simple sum, straightforward. Sin theta is 3 by 5. Theta is in quadrant 2. So if we want to find cos, just square sine, you will get sine square theta, which is 9 by 25. Sine square theta plus cos square theta is equal to 1. So cos square theta is 1 minus sine square theta. So in our case, 1 minus 9 by 25, which will give us 16 by 25. But that is the value of cos square theta. We want cos theta. So cos theta will be square root of both sides. You will get plus or minus 4 by 5. But whether it is plus 4 by 5 or minus 4 by 5 will be decided by the word quadrant. So which quadrant are we in? We are in the second quadrant. In second quadrant, what do we know? In second quadrant, sine is positive, cos becomes negative. So cos theta will be minus 4 by 5. So the moment you got sine and cos, the other functions are a breeze easily. So sine theta is 3 by 5. So cosec theta is 5 by 3. Cos theta is minus 4 by 5. Sec theta is minus 5 by 4. Sin 3 by 5 and cos minus 4 by 5. So tan theta is minus 3 by 4. So cot is inverse of tan. So you get minus 4 by 3. Please take this sum down. Let us move ahead. Prove that root 2 into sin pi by 4 plus theta is equal to cos theta plus sin theta. So let us go for it. What is our LHS? Left hand side is root 2 sin pi by 4 plus theta. So what is pi by 4? Pi by 4 is 45. So root 2 sin 45 plus theta. This root 2 is multiplied to the sine function. So we keep it outside the bracket. Inside the bracket, we apply the formula of sin a plus b. What is the formula? Sin a multiplied by cos b plus cos a multiplied by sin b. So it will be sin pi by 4 cos theta plus cos pi by 4 sin theta. What is the value of sin pi by 4? Sin pi by 4 is sin 45. That is 1 upon root 2. Cos theta will come down as it is. Cos pi by 4 is cos 45, which is 1 upon root 2. Sin theta will come down as it is. So we have cos theta upon root 2 plus sin theta upon root 2. So we can write it as cos theta plus sin theta upon root 2. As you can see, this root 2 and this root 2 gets cancelled. So we are left with cos theta plus sin theta, which is what we wanted to prove in the first place. So we get our solution. Root 2 into sin pi by 4 plus theta will be equal to cos theta plus sin theta. So now we can write down a formula which is sin 45 or pi by 4 plus theta will be cos theta plus sin theta, cos theta plus sin theta, whole thing divided by root 2, whole thing divided by root 2. So you can separately jot this down. If you have understood this, please try this sum on your own. You want to prove root 2 into sin pi by 4 minus theta will be cos theta minus sin theta. Please try this sum on your own. Let us move to the next sum. So whatever we did with sin, let us try with cos. The sum is root 2 cos pi by 4 plus theta is equal to cos theta minus sin theta. So again the steps will be same. This root 2 we keep outside the bracket. Inside this bracket we use the formula of cos a plus b. What is the formula? Cos a cos b minus sin a sin b. In our case it will be cos 45 cos theta minus sin 45 sin theta. What is the value of cos 45? It is 1 upon root 2. Cos theta comes down as it is. Sin 45 is again 1 upon root 2. Sin theta will come down as it is. So what do we have inside the bracket? Cos theta minus sin theta upon root 2. So this root 2 will cancel out with this root 2. So what will remain? Cos theta minus sin theta. So root 2 cos pi by 4 plus theta will become cos theta minus sin theta. So similarly solve for root 2 cos pi by 4 minus theta. Again can we derive a formula? Cos 45 plus theta as cos theta minus sin theta whole thing divided by root 2. So cos 45 minus theta will be cos theta plus sin theta upon root 2. Please try to derive such formulas as much as possible. We want to find the value for tan pi by 4 plus theta and prove that it is 1 plus tan theta upon 1 minus tan theta. So what is our formula of tan a plus b? The formula of tan a plus b is tan a plus tan b upon 1 minus tan a into tan b. Please check the formula. It is tan a plus tan b upon 1 minus tan a multiplied by tan b. So what is our a in this case? Pi by 4. What is our b in this case? Theta. So tan pi by 4 plus tan theta upon 1 minus tan pi by 4 multiplied by tan theta. So what is tan pi by 4? Tan pi by 4 is tan 45 whose value is 1. So tan pi by 4 becomes 1. Tan theta comes down as it is upon 1 minus tan pi by 4 which is here comes as 1 here, 1 minus tan theta. So you have 1 plus tan theta upon 1 minus tan theta. 1 plus tan theta upon 1 minus tan theta. Similarly, you can derive tan pi by 4 minus theta as 1 minus tan theta upon 1 plus tan theta. Very, very important formulas. Please mark this down as formulas. Let us continue. Cos 27 plus sin 27 upon cos 27 minus sin 27 is equal to tan 72. So when you get such kind of a sum, first of all you have to relax and think. What is there on your LHS? On your LHS you have terms in sin and cos. On your RHS there is only one term which is related to tan. So somehow we have to get terms in sin and cos to term in tan. So how do we do that? Whatever is sin, you have to divide that by cos. Whatever is sin, you have to divide that by cos. That is step 1 in your process of thinking. Step 2, you should think why these random numbers 27 and 72 must be given. There must be some mathematical link which can bring us there. So let us try and explore that. So step 1, cos 27 plus sin 27 upon cos 27 minus sin 27. So I want to bring tan in my numerator. So I divide my numerator by cos 27. If I do that, I divide by denominator by cos 27 as well. So what do I get? Cos 27 upon cos 27 becomes 1. Sin 27 upon cos 27 becomes tan 27. Again, cos 27 upon cos 27 becomes 1. Sin 27 upon cos 27 becomes tan 27. So what have we got? 1 plus tan 27 upon 1 minus tan 27. So can you compare this with 1 plus tan theta upon 1 minus tan theta? What is this a formula of? Obviously we learned it right now. Tan pi by 4, which can be written as 45 plus theta. What is theta in our case? The theta in our case is 27. So we can write it as tan 45 plus 27, which will give us tan 72. Tan 45 plus 27 will give it us as tan 72. So the moment you got 27 and 72, you should start thinking whether there is some relation with 90 or with 60 or with 45 or with 30. You will find there is a relationship with 45. 45 plus 27 is 72, and that is another way of solving this sum faster. Please take this down. Let us move ahead. Try these two sums. Cos 11 minus sin 11 upon cos 11 plus sin 11 as cot 56. Cos 15 minus sin 15 upon cos 15 plus sin 15 as 1 upon root 3. In both the sums, I would suggest you stick towards getting something in tan, because tan and cot are interchangeable. You get an answer in tan. Can you then relate it to cot in the first sum? We have a formula of tan a plus b and tan a minus b. So try and manipulate that formula so that you get this answer. Please try the sum on your own. So to give you a small solution, cos 11 minus sin 11 upon cos 11 plus sin 11 will get converted to 1 minus tan 11 upon 1 plus tan 11. This is a formula of 1 minus tan theta upon 1 plus tan theta, that is tan 45 minus theta. In our case that will be 11. So we get tan 34. Can I write tan 34 as tan 90 minus 56? Tan 34 becomes tan 90 minus 56. What is tan 90 minus theta? Tan 90 minus theta is cot theta. So we get the answer as cot 56. So similarly try the second sum. You should be able to get the answer. Sin theta minus pi by 6 plus cos theta minus pi by 3 is equal to root 3 sin theta. Root 3 sin theta. So sin theta minus pi by 6, can we use the formula of sin a minus b? It will be sin a cos b minus cos a sin b. So cos theta minus pi by 3, we will use the formula of cos a minus b, which is cos a cos b plus sin a sin b. Put these in two different brackets. Please understand the importance of brackets. So sin theta into cos pi by 6. So cos pi by 6 is cos 30, which is root 3 by 2. Please observe, I have written it in a specific manner. I have not written it as sin theta root 3 by 2. but I have written it as root 3 by 2 sine theta. This is the proper way of writing in trigonometry. So again here sine pi by 6 is sine 30, which comes down as half. Cos theta will come down as it is. Cos pi by 3 is cos 60 will come down as half. Cos theta comes down as it is. Sin pi by 3 is sin 60 is root 3 by 2. It comes down here. Sin theta comes down as it is. So what do we have here? Root 3 sin theta by 2 minus half cos theta. So in both the cases, in both the terms, 2 is there in the denominator. So can we write root 3 sin theta minus cos theta upon 2 plus, similarly on this side, cos theta plus root 3 sin theta upon 2. As you can see in both the cases, in both the brackets, 2 is there in the denominator. So we can have one numerator which says root 3 sin theta minus cos theta plus cos theta plus root 3 sin theta, whole thing divided by 2. So minus cos theta plus cos theta gets cancelled. Root 3 sin theta plus root 3 sin theta gives us 2 root 3 sin theta. 2 root 3 sin theta upon 2. 2 and 2 gets cancelled. The answer is root 3 sin theta, hence proved. Two sin theta plus pi by 3 is equal to cos theta minus pi by 6. This is given. Prove that tan theta plus root 3 is equal to 0. Prove that tan theta plus root 3 is equal to 0. So here we write this 2 outside the bracket. Sin theta plus pi by 3 is the formula of sin A plus B. By now we know it is sin A cos B plus cos A sin B. So in our case it comes out as sin theta cos pi by 3 plus cos theta sin pi by 3. So cos pi by 3 is cos 60, which is half. So these two terms will converge as sin theta by 2. Sin pi by 3 is root 3 by 2. So this will become root 3 by 2 cos theta. On your RHS, you have cos theta minus pi by 6. So it will work out as cos theta cos pi by 6 plus sin theta sin pi by 6. So you will get it as root 3 by 2 cos theta plus sin theta by 2. So here on your LHS, the denominator is common, which is 2, which you can write here as 2, which is there outside the bracket, sin theta plus root 3 cos theta whole thing divided by 2. This 2 and this 2 will cancel and give us sin theta plus root 3 cos theta is equal to root 3 cos theta plus sin theta upon 2. Now this 2 will move to the LHS, and will be multiplied as 2 sin theta plus 2 root 3 cos theta is equal to root 3 cos theta plus sin theta. Bring everything on the left hand side. So 2 sin theta minus sin theta will be sin theta. 2 root 3 cos theta minus root 3 cos theta will be root 3 cos theta is equal to 0. So now we are at this stage. On our LHS, we have sin theta and cos theta. On our RHS, we have a 0. And what is asked in the sum? Tan theta is asked in the sum. So what do? We have sin and cos. So divide all that is sin by all that is cos. So we divide LHS and RHS, that is left hand side and right hand side, by cos theta. So we will get sin theta upon cos theta plus root 3 cos theta upon cos theta is equal to 0 upon cos theta. So sin theta upon cos theta will turn up as tan theta. This cos theta cancels. Root 3 comes down as it is. 0 comes down as it is. because 0 upon anything is 0. So you will get tan theta plus root 3 as 0. Let us move ahead. Cos 35 plus A into cos 35 minus B plus sin 35 plus A into sin 35 minus B is equal to cos A plus B. Now when we get this sum, initial thought process is I will have to apply the formulas of cos A plus B, cos A minus B, and the sum will become large. Rather than doing that, look at this entire sum, which is your left hand side of the sum, in one frame. So what will you realize? There is cos of an angle multiplied by cos of another angle plus sine of an angle multiplied by sine of another angle. So do you find a trend? Cos of an angle multiplied by cos of an angle plus sine of an angle multiplied by sine of another angle. So cos plus sine. So if you look at your formula sheet, somewhere it will click that let us put 35 plus A as P, 35 minus B as Q. So what do we get? Cos P multiplied by cos Q plus sin P multiplied by sin Q. This is the formula of cos A minus B. So you get cos P minus Q. Resubstitute P and Q. So you will get cos 35 plus A minus 35 minus B. Please have a look at the use of brackets in this case. Please use brackets properly. If you don't use brackets, you will make an error. So when you open the brackets, you will get cos 35 plus A minus 35 plus B. This minus and this minus becomes plus. So 35 and minus 35 gets cancelled. What comes out? Cos A plus B. There is this simple trick involved in this sum. Let us move ahead with a similar sum. Cos pi by 4 minus x into cos pi by 4 minus y minus sin pi by 4 minus x into sin pi by 4 minus y is equal to sin x plus y. So we use the same trick. Let pi by 4 minus a x be equal to a, pi by 4 minus y equal to b. So what will happen? The original sum will become cos a cos b minus sin a sin b. So cos a cos b minus sin a sin b is cos a plus b. Resubstitute the values. You will get cos pi by 4 minus x plus pi by 4 minus y. Open the brackets. You will get pi by 4 plus pi by 4 minus x minus y. So I have written is at minus x. Put a bracket and use x plus y inside the bracket. Please check this maths. So pi by 4 plus pi by 4 gives you pi by 2 minus x plus y. What is cos pi by 2 or cos 90 minus theta? Cos 90 minus theta gives you sin theta. In our case, what is the theta? In our case, the theta is x plus y. So your answer will be sin x plus y, which is the correct answer. Try these two sums on your own.